it is doing another comparison, and here is another loop. You always want to find the loops. In either the loops, you can see this green one is telling us there is a loop there. Okay, so we are going to go to the loop, but we need to see the calculating value, the values being calculated. So it's saying move EX to DL and compare that value with the content of ECX, right? So let's see what is that. EX, if we click on it, we can see that it was assigned right here, right? So we don't know what it is. The debugger is going to tell us what is this value. Then ECX. ECX is saying, oh, ECX is going to be pointing by 68. Oh, but this 68 was assigned right here with the move. Move to 68 EX. And EX was here moved by this guy, which is a double word, right? This double word, if you double click, you can see what is the content. In this case, is this value. If we right click, oh, well, we can, well, anyways, it is also something difficult to see, but I can tell you guys that here we can see that this guy has these values, right? 64, 63, 62, 61, and then there is no 0, which means it's not the end of it. Then it has the 66, 65, and then a 0. That means this whole thing is the same. In other words, these guys is the password that we need to enter, but it is in reverse order. 61 is A, 62 is B, C, D, E, and F. So basically what I'm saying here is the password expected, it is A, B, C, D, E, F. Now, this value, as we know, is being passed to one of the buffers to be comparing to. That's why we know it is the password. So if we click on X here, I'm gonna take advantage to show you something. If you don't know what is that specific value being used, you click in X, which is X reference. It's gonna tell you where that value is being used. It is gonna show you the different options where it is being used. You double click and you go exactly to that location. So we can see that that value is moved to EAX, which is the initial value of a string, right? That value is eventually moved to bar 68. We can click on that value and put like an N and say real pass, for example. So we can label it. Now we know that this value, it is moved to ECX, and now that value is compared with DL. DL is coming from EX, which is assigned right here. This value must be, or should be, the password that we entered. Okay? And here is gonna compare it with the real password. So let's see that in IDA. What we can do is, we can click space, see the address is 1090, okay, and we can go to the debugger, and we can go to the 1090 address, which is right here. Press F2, press F9, and we jump right there, right? So let's see how that works. EAX, you can see that EAX is pointing to our password that we enter, and you can see that ECX is pointing to ABCDF, ABCDEF, which is the password that is supposed to be entered, guys. You see that by going to the debugger, we can confirm at runtime. So what it's doing here is gonna say, hey, move to DL that value. Okay, so DL has 63. Compare that value with ECX. In this case, as you can see here, this is very useful window. So it is saying, okay, so you have DL, which is C, and comparing with something, which is ECX, which is pointing to 74, which is A, right? Those are different. And therefore, the comparison is not gonna put the flag. The flag, you can see, it is 0. It's not gonna be set, because keep in mind, it is only set if the values are equal. And therefore compare is gonna return 0, and therefore the flag is gonna be set. Since they are not equal, the flag is not set, and then jump not set or not equal is going to be taken. You can see here it says jump is taken, and what it's going to do here is not click here, so come back to the IDA. It's going to say, hey guys, if this is not the same, jump here, which is basically getting out of the loop, put some value in EAX, and then compare it finally. So here we have two options, as you can see. Either this value, which probably it is something not zero, we're going to confirm that, and in the left side it is saying XOR EAX. In other words, if you didn't get out of the loop but you follow the proper process normally, you will exit properly, so EX is going to be 0. Keep in mind that XOR EX is to set EX to 0, and then it's going to say, hey, test EX, which means, are you 0? If not, wrong password, and if yes, congrats. Okay, in our case it's saying go here, which is going to put a non-zero value in EAX, and it's going to go to wrong password. So let's check that. So we take the jump, okay, so check that is a SBB EX, it sets to 0, then subtract 1, which is setting 1 in EAX, and then it says test EX. It's saying, hey, are you 0? 0 flag is not altered. Jump if not 0, we jump, and then we get the wrong password. We go to the string, and we get the wrong password. Okay, guys. So, but we saw that our program, it is actually expecting A, B, C, D, E, F, right? So in other words, if we rerun this program again, I'm gonna press on F9 because normally the pointers, the breakpoints are saved. Okay, it's running. I'm gonna enter the password A, B, C, D, E, F. Enter. So we get to the loop where we're going to start comparing, guys, again. Let me put it up. And now we can see here that it is saying move EAX to the L, which in this case is A. And then it's going to say compare A with A. We can see AX and ECX is exactly the same. Compare is going to set the flag to 1 because it is 0. In other words, compare is going to return 0 when those strings are the same. In other words, and then the flag is going to be set. You can see there. Then the jump is not going to be taken because it's saying if not set jump is not the case. Then it's going to check just that if it is test DLL, which means are you 0? In other words, are you the end of the string? Jump equal? No, it's not the end because again the flag was not set. On actual, well, was not set. And then we said, okay, so move to the next one, EX plus 1. EX plus 1 is the letter B. And compare it with ECX plus 1, which is also B. Hey, are you not the same? No, we are the same. We don't take the loop. Sorry, we don't get out of it. Since we compare 2 bytes or 2 chars, we jump over 2 instructions after. And then we compare again if it is the end. And then we come back again. And here's another trick, guys. Since we know that it is comparing everything, sometimes you will have a really big loop. So what you can do is always you can go after the loop and put a breakpoint just after it. And remove the previous one. And then click F9. And we finally get out of the loop quickly. Right? We see that we jump into the XOR EAX, which is saying we get out of the loop properly. EX is set to 0. We jump. We said, hey, EX is 0. The 0 flag is going to be set. And then we jump there, which says, congrats, password found. Okay, guys. So, it is print in the screen. So, as you can see, guys, we found different ways to interact with the debugger. We found how we can compare IDA and the debugger in order to understand the different instructions. We saw how we can confirm something that is not clear in IDA, but the debugger can help us. We can also see that in IDA we can have a better documentation of the functions, or we can also check that IDA has a better flow understanding, so it is always playing with both sides of the puzzle, guys. Okay, always playing with the debugger and IDA in order to have a better understanding. So finally, let me show you that if we, for example, close this guy, which is IDA, we close it. Since it's a SPAC database, we said okay. If we open, guys, our if we open our example exercises, you can see that IDA created an IDB. This IDB is actually a database that stored all our changes. If we double click on it, it's gonna be picked up because of the extension by IDA. And basically IDA is gonna say, okay, so I'm gonna load the same, oh no, oh don't worry, we can just click in IDA. Actually here was, the operating system was not able to recognize it. We click on IDA, okay, we click on new, and then actually we just click on open. We click on the IDB, and you can see that IDA is gonna open our binary and is gonna print our comments. You remember we enter these comments, it is gonna be saved there. In other words, whatever we put in our analysis is gonna be stored. And it is very useful because you can share the IDB analysis with other of your teammates if more than one person is doing analysis. Okay guys, so last but not least, I want to show you how you can quickly patch a binary. Sometimes you want to patch a binary because you want to change the flow execution. So let's say that there is a, like right here, right? So let's say that instead of saying wrong password and you don't want to know the password, or it is hard to find it, so you can put up here in this decision, jump decision, you can change it to the opposite meaning, so that it is gonna jump into the congrats when it is a wrong password, and it's gonna jump into the wrong password when it is the right password. In other words, if you change it, you can always put any password and you will get always the congrats password. I mean, that's kind of a quick example for you guys, but let's say that you are going into a decision like anti-virtual machine checks in the malware, and it is always jumping to the exit function if it is found to be running through a debugger. So you can always change the jump logic to not jump, so that you can trick the malware and force it to keep running even through the debugger. So that's kind of most of the options that you will always use. So let's do an exercise here, and let's change this value so that anytime you put any password, it should say congrats. So what we need to do is we need to change this jump not 0 to jump 0. You know, just changing the opposite. So we know that if EAX is 0, it will jump to congrats. But we are gonna say jump if, and then if it says jump not 0 to wrong password. So we're gonna say jump 0 to always, jump 0 to wrong password, and not 0 to congrats. Sorry guys for the confusion, but it's gonna be clear in a second. So we're gonna do this, guys. So let's go to here to the debugger, and I'm gonna restart it with this button. We said yes, we're restarted. We click F9. It is waiting for our password. Okay, so we'll put whatever we want. We click enter. It is terminated. Sorry, I missed to put a breakpoint. I will run it again. F9. So here I'm gonna need to put a breakpoint, guys, and I'm gonna put a breakpoint in the decision, right? You remember there is a decision. It is hard to follow, so we can always go to IDA, check this guy, click space, and we know that it is in the 10b7 is instruction. So we come back, we go to 10b7 is right here, we put a breakpoint right there, okay, and we let it run. It's gonna wait for our password, we put everything, it jumps into the decision, and here we know that in this case, since it is a wrong password, it is gonna say jump is taken, because it is always saying that if it is not 0, which means the password is not the right one, jump to wrong password. Here we can jump, we can force it to always jump to congrats. So we double click on this guy, and here we can say jump 0. And then we click on assemble, and check here guys how the opcode is gonna change. Right now it is 7511, and see this, assemble, and it's gonna change to 7411. In other words, 74 is equal to jump 0, and 75 is equal to jump not 0. Okay guys, so here we change it. Okay, so now if we come, we have two options. We can save this binary by doing right click, okay, then we go to copy to executable selection, which is basically copying this guy 74 that we just changed into the executable, and we say save file. Okay, so let's say that we put here find password cracked, okay, and we save it. So now we have a modified password, right? So in other words, if we open it in the console, so let's say we go to documents, we go to exercises, we go to RE, we have here our new one, which is find password cracked. We click, enter password, we put everything, and it say congrats, right? Everything we put, it will say congrats. So as you see, we changed the the logic, so it will always force. Now this is one way to patch it, but let's do it in a different way. So this is one option to patch it, right, via the debugger, but sometimes it's not possible, or there are many other scenarios. So let's say that we want to patch it right directly into the binary itself. So we know that the address is 10b7, right? So what we can do is we can open like any hexadecimal editor. So we can go here, we can use Hiew in this case, the demo version. We'll go to RE, and I'm gonna open this guy password, but before doing that I will close this guy. It's gonna throw some errors. So I click on find password, okay, and then here we can do an enter, and then we can go, we press F5 to go to the option, which is 0040, which is the base address, and then 10b7, which was the address where was the instruction. We click there. If we can see that we have here, right here, the 7511, right? If we actually click on enter, I didn't follow properly. Yeah, right here, we click enter, we can see that we are in the jump not 0. So we can see again that it is exactly the instruction that we were looking for, right? Here we can press F3 to edit, okay, and here we're gonna change this guy to 74, and check how the instruction is gonna change. As expected, now it's changed to jump 0, and now we press F9 to update the binary. Okay, so now we have changed directly into the hexadecimal bytes the binary, not via the debugger, right? So we have now our find password changed. We exit, and now if we run our find password, not the crack one, we change the original one, and we put whatever, it says congrats, password found. Okay guys, so these are two easy ways so that you can always change. One of the things that you need to keep in mind is you need to know the opcode to change, right? If you don't know that 74 is going to be the jump 0, the easy way to know that is go into the debugger, as I explained you, put your assembly instruction, move, jump, whatever, and then it's going to be translated into the opcodes. Grab those opcodes, and then you know what are the bytes in order to patch the binary.